All right, happy Monday to you. Just kind of want to go over what we did in class today, kind of rather quickly. Make it a short video as I can. 21, 22, 23 on the set. I'm not doing anything before that. And then a little bit about the go, just the first couple of problems is really all we did today in class. So this first one, a couple of things to note about it. It says given ABC is 90 degrees. You want to notate that on your diagram. And we want to list all the given. Well, everything that we were given, we listed. So now we got to stop back and we got to think. And one of the topics that came up in class was, hey, well, they all form a straight line. You're right, but they all do form a straight line. So when they all form a straight line, what does that equal? A straight line from last week equals 180 degrees. Well, how do I equate that? What do I do? The consensus in class came up and said together. Well, together means we add. They all add up to equal 180. So if they do, 3x plus 90 equals 180. We're going to subtract 90 to get 3x equals 90. We're going to divide by 3, and x is equal to 30. If x is 30, then up here, this angle, whatever this angle would be, it doesn't have a variable over here, so I can't name it, but this angle here would be 30. I know that this one's 90, it's notated right there. And this one's 2 times x. Well, if x is 30, that means this one's 60. Okay? The next problem is going to be a bit lengthy, but I'm going to break this up and try and make this as easy as I can for you. I'm going to have to move the camera anyway. I'm going to try and get everything else in one shot. I'm going to have to move it. Well, what do you see? On this particular figure, I see it has 4 sides, but if I look deeper, it's got a small triangle, a medium, and a large. Label what you're given. Well, G, triangle BEC. BEC, and this is in E right here. BEC, okay, that would be the medium. CED, CED, that would be the small triangle. DAB, that would be the large, are right triangles. Well, if they're right triangles, then this here's a right angle, this here's a right angle, and A is a right angle. So I put the elbow there. And it wants me to be able to find x. Okay, well, x is a part of the small triangle, so I'm just going to go ahead and draw that figure first. And that is triangle CED. So here's my triangle. And it's a right triangle, and I know my sides are 6 and x. Question in class was, if I know 2 of the 3 sides of a triangle, I can find the third. But do I know 2 of these sides? All I know is one is 6, the other one is x, which I don't know what x is. So I cannot use the Pythagorean theorem, a squared plus b squared equals c squared, for this particular figure. I would have to know something else, something I haven't taught you yet, which we actually would have to know an angle. We haven't even talked about that yet. So I can't really do anything with that triangle. Okay, well, let's move on to another one. Let's move on to the medium-sized one, the one that came with first, which was triangle BEC. That's this triangle here. And notice what I'm doing by drawing these individual triangles. I'm focusing on just this specific figure instead of seeing all of this and trying to have it confuse me. I know the bottom here is 14 and this side is 6. Yes, for this one, I do know 2 of the 3 sides. So 14 squared, which is the hypotenuse, is equal to 6 squared plus b squared. And you got to go through ahead and solve. All right? So I'm going to give you a second to go through and pause and see if you can figure out what that is. I'm not going to do the work for you. I did that in class today. All right? You should get 12.6, roughly. That's what you should have gotten. Again, you got to show your work. You don't show your work, you're not going to get credit. So over here, I'm going to label this 12.6. Now the only other triangle I haven't dealt with is the large one. And in simplifying the medium one, that still doesn't help me with this side, okay, which would be right here. So I got to go to the large one. Well, here's my large triangle. Again, it's a right triangle. I have a side that's 8 and a side that's 15. And what are those sides? Are they legs or hypotenuse? Because Pythag states that one leg plus another leg is equivalent to the hypotenuse. If I square and add them together, that equals the hypotenuse. Okay? That's just a formula for Pythag. Well, up here, what do I know? This is the hypotenuse, okay, longest side. So it's 8 squared plus 15 squared equals x squared. Take a few minutes and go through and solve. Pause and solve. I dare you to try. Now, you went through and you should have used your calculator. That's what they're for. Have them, use them. You should have gotten 17. So, over here in my diagram, remember, what are we finding? We're finding this segment here, which is DB, or 17. How I notate that is I do this so I know that 17 is the whole segment. Still didn't find this short segment, but I know the whole segment, I know part of it, I should be able to find this. So BD is equivalent to 17 minus 12.6, which is 4.4, which is this side, 4.4. Now I have enough information to be able to find x, which is really what they want. Remember, think about what your sides are. X is across from the hypotenuse, so that's my C value, is equal to 4.4 squared plus 6 squared. And go through and solve that. All right, so take a minute and solve that, and come back, pause it. I dare you, pause it. Come on, just use a calculator. It's really not that hard. And then you should have gotten 7.4. And the last thing you ask yourself is 7.4 a reasonable answer for the length of the hypotenuse? Yes. This is 6, 4.4, 7.4 is reasonable. All right, the last thing I'm going to cover today, just because I'm kind of running out of time here, is the angle bisector one. It talks about CF bisecting ECD. So find E, find C, and find D. What does a bisector do? A bisector bisects something into two equal parts. Okay? Make a note of that. Two equal parts, right here. Right? It divides it. Now, how do I notate that? You're going to notate that with two arcs. You must stagger these arcs. You can't draw them next to each other. Okay? See how I staggered them a little bit? You have to do that. And that's how I'm doing that in here. Think of a piece of rope. I use this example. I take the rope, I want to cut it in half, but I don't have a measuring tape. I put the two ends together, find the middle, cut it in half. I bisected it. That's exactly what we're doing to this larger angle here. This CG, that might as well not even be there. They just put that there for no reason, to kind of toy with your head. Well, ECF is 2x plus 10. FCD is 3x minus 18. And what do we know about these two? This is where we've got to think. This is where the disconnect, I think, comes in with students. We don't understand. These two angles we said are equal to each other. Think about what that means. They are equal to each other. How do I create a statement? Because I said a statement. How do I create a statement to solve for x? Because if I know x, I can just plug x in here, and I know the measure of my angle. Well, think about what they said. They are equal. So what does that mean? They're equal. They're equal to each other. And you solve. So you can begin anywhere, one of four ways. If you go through and solve, and again, show your work, you should get x equals 28. Okay? Pause, do the work, make sure you get 28. And when you come back up in here, that's going to be 56 plus 10, which is 66 degrees. Not 60, 66. Okay? So last question here. If ECF is 66 and both of these angles are equal, what's the value of FCD? Yes, it should be also 66 degrees. Okay? Think about what we said down here. They are equal to each other. Think about that. Okay? If you have questions on the go part, right, just ask me, I'll help you with that.